In this video, we're going to talk about the grading and drainage plan. Now, in this plan, typically we don't have our alignment labels on. So I'm going to go ahead and freeze those off. So I'm going to double click through the viewport, and I'm going to go to the freeze button here at the top. And I'm going to freeze off the labels. Okay. In here we would have, but we haven't designed them yet, we would have the we have the storm labeled, but we would have the sewer and water lines drawn out. But we're not going to do that in this class. We're going to leave that out. But you would have where the sewer mains are and the water mains. I've shown you how to do that in the other tutorials, but I'm not going to do it in this one. So I'm also going to go ahead and click off the basic, and I'm going to move the lot names so we can see the lot numbers. Now, when we're talking about grading, we have various types of grading. When we have lots that are adjacent to other properties, we typically drain toward the front of the street, and that's called an A drain. When we have lots that are adjacent to ponds, we might split the drainage and send the water half to the pond and half to the front of the street. So I'm going to show you on some of the stuff that I've uploaded to Blackboard and explain a little bit about the paving, grading, and drainage of lots. So if we start with the grading, I created a PowerPoint, and this is uploaded into Blackboard. If we were grading lots, we have to establish the front lot grade first, and the front lot grade is usually established off of the center line of the road. For example, we have a 12-foot road lane in this example, a 2-foot curb, 3 feet, 7 feet. Now, if we're looking at this, we'll assume we've got our profile designed and we have the elevations on our center line. And the other thing that we need to know is what our actual roadway is looking like. So it's going to be a 12-foot lane at 2%. So it's falling away from the center line. And then we have a 2-foot curb. In this type of curb, the F curb has a 6-inch rise from the bottom to the top, from the edge of pavement to the top, approximately 6 inches. You'd have to look at the DOT index. We have a 3-foot grass slope or grass area with a 6% grade that's draining toward the street, and then 4-foot sidewalk that has a 2% cross slope, and then we have a 4-foot grass area with a minimum of 1%, and that's going, all of this area here is draining to the curb and gutter. So what we're going to need to do is we start with the center line of the road. So we got to find the center line of the road in the plan and profile. So if we assumed that the elevation just at dead center right here was 100 feet, we do 12 feet at a negative 0.02 because we're going down this direction, and we subtract it from the 100-foot elevation that was here. Then we're going to have that the 2-foot curb, we're going to rise 6 inches. So we're going to take that elevation that we just figured out here, and we're going to add the 1/2 foot. So it goes from 100 minus the cross slope of 0.24, so we get 99.75 right here at this point right here. And then we're going to take that elevation and we're going to add a 1/2 foot. Now, once we get to the top back of the curb, we're going to take the 3 feet at 6%. The 6% comes from typically the land development code or the codes for the county jurisdiction that says, okay, this is typically how we see our roads designed. So they'll have standards of what that slope area is. In Osceola County, we've always used 6%, so you'd have to check where your county is. So I'm just using Osceola County standards. Then we're going to add that information, that 3 feet at 6%, to the previous elevation. From there, we've got a 4-foot sidewalk at 2% cross slope. That is minimum 80A, so you can't have more than 2% cross slope on a sidewalk. So we're going to add that 2% at 4 feet to the previous elevation at this point right here. So it's going to be, the next point is we're going to have a 4-foot grass area, and it's at 1% in this area. Okay, so that's arbitrarily. Usually I would use 6%, but I was just being different in this this calculation. It should have been 6%. I try to keep 6% in this area so the right-of-way always drains to the street. And so that gives me an elevation of 100.56. And the centerline elevation was 100. So the difference between those two is the 0.56. Okay, so now I could, if I don't use a surface that I've created from the corridor, then I would have to do these calculations by hand for every different type of roadway that I had. Now we need to look at the type of lot grading. So in lot grading, if we have a road and we have lots behind or attaching to an existing, another piece of property, we need to drain everything to the front. But here's the thing, is if the lot, the existing ground elevation in the back is lower, then we have to slope down. So if we had an elevation, let's say here at 128, and that elevation back there is at 122, and we have to have a grading to the road, then we can't send the grade back. We have to come up at 1% and then figure out what that distance is, because we can't have more than a 4-to-1 slope at the back slope to the existing ground elevation. So in this example is if the road was higher than the back of the property. So we have to look at our project to see if the front elevation is higher than the back elevation. And then the majority of our project that I'm going to be showing you, it's going to look like this. So we're going to have to figure out this area, or this distance here. Now, basically, we're just looking at the slope of a line. So I'm going to take this point right here, 128, and I'm going to add 0.01, which is some type of percent, times 120 minus x. This x is going to be the distance between here and here and here from these 2 points. I don't know where this information here is taken from, this information down here. So I put an x as arbitrarily. So I don't know how far away I have to be from the back of the property line to get this slope to come up and have a 1% here. So I put the x here, and I know that I'm going to use a 4-to-1, and I'm going to connect down to existing grade at 120 elevation. So I set these two equations equal. 128, that's the front grade, plus 0.01 times 120, that's the total length of the lot, minus some type of distance, okay, which is going to be equal to 120 plus a quarter, 0.25, which is the 4-to-1 slope, times x. So this elevation here has to be the same when I calculate it from this direction and this direction. And I do that again for this side here. So when I solve for x, it's saying basically this distance here has to be approximately 35.4 feet. Okay, so I'm going to round, and I would round it to 35 because you can actually have a 3-to-1, but I try to keep it a 4-to-1 slope back here. I may have used 36 at that point in time. And I solve for that actual elevation. I do that at each one of these points. So for lot grading A, reminder is we're going to grade at 1%. We're going to come up and we're going to look at whichever's higher and come up to 1%. Look at this one, we're going to come up 1%, approximately 20 feet. That's usually the setback from the back of the house. And we're going to add 8 inches to get the finished floor elevation. Now in this one, we have the elevation, and this is so much higher, the existing ground is so much higher than the front of our lot. So we don't want a steep grade from the back to the front, so we'll actually do a 4-to-1 down and then a 1%. Again, it's the same process. We have 120 feet is the total length of the lot, but we need to find out what that distance is to solve for where this point is, where these two, when calculated, equal the same value of elevation. So notice, I have 128.18 plus 0.01 times 120 minus x. That's this distance here. Set equal to 135.8, that's this point here, minus 0.25 times x, because I'm going down. Notice this one's going up and this one's going down to solve for this point. I'm going to let you all review these calculations. If you have a question on that, send me an email. So I'm going to go to the next one. Now, when we're looking at B and C grading, when we're grading, typically if we have a type B, there's usually a pond or a swale, and we're going to have the road elevation, and we're going to set a high point approximately the center of the lot line, the midpoint of the lot line. Then what we have to do is we have to look at which one has the higher elevation. So our road's going to be the higher elevation in this example, and we're going to grade up 1%, and usually we let whatever calculates down, but it has to be 1% back down. If not, then we might move where the high point is on the lot line. We find out where the midpoint, the high point on the midpoint of the lot line is, and we come up to the center. So if the lot is 50 feet wide, after I set this high point on the mid of the lot line, I look at which one's greater, and then I take that and I add 1% to the center, and then I add 6 inches. Sometimes I take it in at, should have been 25 feet to the center, but for whatever reason I used 20 to get to the center of the lot, and then I add the 8 inches. Okay, and then I set my finished floor. Now, C lots are when you have so much of a higher elevation, and it can drain naturally all the way back to the back of the pond area or to an off-site drainage swale. So notice I'm going from 128 to down to 125. And that's approximately 2.5%. Now, here's the thing, is we do go up about 25 feet at 1% and then add 8 inches to get the finished floor elevation. The reason we do that is because we don't want water to drain into our garage, okay? So C lots drain backwards from the front of the road all the way back, all right? So that's the end of this presentation. So let's go back to our grading. Here's another example. It's also in the Blackboard. Is an example of how these calculations work to get your elevation, and then examples of how to step by step calculate the grading for a type A lot, and then grading for how it looks on the site plan. So these are step-by-step calculations of how to set the high points and how to figure out finished floor elevations. So you'll want to take a look at that. And this is just an example of the A grade. Now, so I'm going to go back to my lots, and I'm going to set elevations along the lot line. So I'm going to go to the model, and since this is existing ground elevation, I'm going to come over here to points and points on a surface, random points. And it says hit the enter key to select the surface, and it's going to be the existing surface that I'm going to select, and I'm going to go OK. Now, I am going to turn my snaps on, and I am going, oops, I should have endpoints on there. And I'm just going to start putting these points in here. I think I missed that one, so there's that one. I'll delete that in a minute. So I'm going to have to tie back into natural ground, and that's why I'm putting these points on here, so I know what natural ground is. And then finish this up down here. All right. Okay. So now I'm going to select these. And select similar, and I am going to change those to elevation only. Go ahead and label those points. All right, so now I've got all my spot grades labeled. If I go back to my paving, grading, and drainage plan, then I'm going to go ahead and close that out. I can see the elevations. I can go ahead and get rid of that one because that one's double. All right, so this one's going from, for example, this is going down from 77 to 70, but these have to be A lots. And the other thing that we typically do is we create we have to put in on these plans. So I'm just going to arbitrarily grab a piece of text. So I'm going to say layer management, layer properties, and create a new layer. And I'm going to say VC lot type. I'm going to make that continuous white, and that's fine. Go ahead. I'll make that current for right now. So I am going to annotate, add a piece of text, and I'm going to say A. And the other thing that we'll need in here is FFE, finished floor elevation. So I'll put it all in the same layer, and I'm going to do that to the center. And it's thinking that text is way too tiny, so I am going to change that height to 2.3. I'm going to move this over. So the other reason I did this is because in the site plan, I don't want this on. So in here, I do lay freeze, LAYFRZ, and I freeze it off through that viewport. And yes, and then I come back to my grading plan, and it should still be on in this viewport. And there it is. All right. Actually, I'm going to change that height to 3. That looks a little bit better. All right. So now what I have to do is I have to look at how I want to grade this out. So I'm going to come in and I'm going to say, if I look at my site plan, these lengths 189, 155, 150, I want a flat air, not a flat, a 1% slope for 100 feet. And then I'm going to confirm that the slope backwards is a 4:1. So to do that, I'm going to do it in model space, and I'm going to show you how this works. Make sure that the only thing checked on in your OSNAPs is node. That's all I want on for right now. Now I'm going to go to the Home tab, and I'm going to go to Points. And this is how we're going to do, instead of us doing all these calculations, I'm going to use these spot grades that I've already set in the front, and I am going to do a 1% slope off of those. So I'm going to go to Points. We're going to create a slope, create point slope, points, slope grade distance. So we're going to go a distance of 100 feet. And I am going to, on this one, I'm going to default styles. I want to change, it has point number, elevation, and description. So I'm going to leave it as is, and then I'll have to just change them as I go along because I don't want to have to get into the whole explanation of the settings and all that. So I'm just going to leave it as is, and I'll change it later. So now down here it says, let me move this over. Down here it says, specify a start point. I'm going to pick a start point, and I'm going to have my snap collect here. And then it asks me to define the direction. And I'm going to shift and right click and go end point, because I want to set the point off of that. The next thing it asks me is, do I want to do rise over run or do I want to do grade? I'm going to do grade, and I'm going to say 1 for 1%. And then it's going to ask me what distance, and I'm going to say 100 feet. The next thing it says, do you want intermediate points? And I say, I'm just going to hit enter because I'm going to accept 0 because I don't want any intermediate points. And then it asks me, do I want to offset? No, I don't want to offset. And then it asks, do I add an ending point? And I say yes. So this is 100 feet out. So I'm going to push this up here. And I'm going to go default elevation only. And now at that point, I have this elevation, and that tells me it's 1% from this point to this point. Now, I can take a look at my annotate, and I can do, if I just click the add labels tab up here, I can figure out from the I'm looking for something specific. I was thinking that I could list the slopes based off of this, but I would have to create a surface first, and I don't have my surface. So I'm going to use this method. I'm going to go to the Analyze tab, and over in the Inquiry pull down there is List Slopes, and we can list slopes between 2 points. So I'm going to list the slope, and I'm going to click on points, and I'm going to start with this point, and I'm going to end with this point. And notice it says -1%. It's a 1 to 100 with a horizontal distance of 100. Now I can do that again. I'm going to click on points, and I'm going to click this point to this point. And that's telling me that it's a -2.88% slope. So I'm okay with that. So the house is going to set up here, and it's going to grade naturally back here. But I may not want that because that's a lot of area that is draining off my site. So what I typically do is I'll take and leave that point where it's at, and I'll come this direction, and I'll go points, create from a distance, and I am going to create a buffer this direction. I would have to do the math, like I showed you in the video, on how far this is. So let me show you the math first, and then we'll hold the one with the greatest elevation difference. So this one's only 77, and that's 76. This is 77, and that's 70. This is 76, and that's 69. So I'm looking at these two lines that are going to be actually controlling my spot grades of how far I should come out for the 4 to 1 slope. So let me show you that. All right, so what I'm going to look at here is I'm going to clear that out. I'm going to take a look at which one has the greatest elevation difference. So I'm going to take the 62.20, and I'm going to take the 69.56, subtract the 2, and I'm going to get 6.64 feet. So there's a drop of 6.64 feet and 155 feet. Now, I'm going to go ahead and start drawing up a sketch. I've got it started, and basically what we're saying is, in this sketch here, we're going from 76.20 to 69.56. So I need to figure out this distance here. We'll call this X. And this distance in blue is 155 minus X. So we're looking for some place here. This slope will be a 4 to 1 slope, or 25%. Okay, whereas this one that we're going to be drawing up is going to come up 4 to 1. Oops, let me erase that. It's not this point here. It's going to be along that. So it's going to go up at a 1% and then come back down at a 4 to 1. So at this point right here, where I'm trying to figure out is this is going to be 1% down to the front. That looks like 17. So this is 1% going that direction. And coming back down to natural grade, it's going to be the 4 to 1. So every 4 feet horizontally, we're going to drop 1 foot vertically, or 25%. So let me pull this a little bit further down. So what this is going to end up being is we're going to take 69.56, and we're going to add, because we're going uphill, some unknown distance at 25%, X, and I'm going to put a little multiplication sign, times 0.25, which is foot per foot, or 25%. That is going to equal 76.20 plus 155 minus X, I'm going to put another parentheses in here, times 0.01, because that's the percent going this direction. So I've got 69.56, sorry for my writing, plus x, well, let me rewrite that a little bit neater. Plus 0.25x is equal to 7620 minus 155.5 times 0.01 is 15, not 15, it's, I'm writing poorly today, it's 1.55. So that's plus, and then minus 0.01x. Now we solve for the x, so we're going to take the 76 to the other side, minus 76.20, and well, we should add these two here. Let's do it that way. Let me clean this up. So we've got my tools, my erase is gone. I want to make this positive, so I'm going to take the negatives to the other side. So I'm going to add on this side 0.01x, and I'm going to subtract on this side 69.56. So I'm going to get 0.26x is equal to 76.2 plus 1.55 minus 69.56. So I'm going to get 0.26x is equal to 8.19. So that's 8.19. Now, to solve for x, I'm going to take x is equal to 8.19 divided by 0.26, which is going to give me 31.5. 31.5. So I like to keep, this is the distance away, 31.5, that I need to set that point. And that point is going to keep this at a 1%. So what I'm going to do is, if I've got, to be on the conservative side, just to make sure that's a 4-to-1, I normally would round this up. I'm going to round it up to 35. If I have an offset of 35 along this back line here, that means 35 feet has to drain off site. There's nothing I can do about it, unless the only way to change that, and I'll change colors, is if I come back in and I put some type of a retaining wall and send everything to the front. But I don't want to do that. I don't want to have to create a retaining wall back here. So I'm going to go ahead and close this down. And what I'm going to start doing is I'm going to take and I'm going to draw a straight line, a polyline, just so I can get my orientation set. I'm going to do P line, and I'm going to go from the end point back here to the end point up here, and I'm going to offset that 35 feet. Now, from there, what I'm going to do is I'm just going to set a 1% slope going out this direction. So what I'll need is, when I come here, so I'm going to go slope to distance, it asks me for my start point. So there's my start point. And the direction is, I'm going to do intersection to this point here. And I'm going to do a grade, and it's going to be 1%. And the distance, and I'm just going to use my O snap at the intersection here. I'm going to hit enter because I don't want any intermediate points, and I don't want an offset point, and yes, I want to specify one. Okay, so that tells me, I'm going to move this down, that elevation there has to be 76.90 to get 1%. Now I want to check my slopes to see what the back slope from here to here would be. and it says it's 19%. It's a little less than a 1 to 5 or a 5 to 1, 20% slope. All right, so that's how I'm going to do the rest of these. So I'm going to go back to the pull down to create points off of a distance, snap to here, intersection here, and grade 1, distance, right click intersection. The reason that I don't have my intersection snapped on is because if this connects to anything but a point elevation, it will put 0 here. Okay, enter, 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 and I'm just going to keep doing this. And snap to here. I'm going to go ahead and let it snap to there. Grade 1, distance, right click intersection. This is a lot more convenient than to do these by hand. The other reason that I'm doing it this way is because when you're grading these for contractor's ease, you don't want this line to meander in and out with slopes. You want a constant ridge line. It's a lot easier to grade. Endpoint, endpoint. Intersection. Now, I'm not going to do all of this because it would take me a little bit of time. I'm going to let you do a few more of them on your own on calculation wise. But I want to go ahead and show you. Ooh, I need to move that over. Make sure when you click, you're clicking on the proper ones. Notice that it went to a 0 elevation, so that's a bad point. So the next thing I want to show you is now for A lots, what we're going to have to do is set the midpoint. So I'll turn those to elevation only. Now when you're looking at this, you're going to look between these 2 points and figure out which one's the highest. And you're going to set it to the midpoint in here. So I'm going to do this again, and I'm going to go slope grade distance, and I'm going to go from this point to this point, grade at 1%, and then it's going to ask the distance, and I'm just going to eyeball it. I'm going to pick what looks to be the midpoint. Usually I do this actually with lines in between, so I can actually snap to a midpoint, but this should work. All right, so once I get that one set, elevation only, then I'm going to come up about 20 feet, and I can type in the values. So I'm going to click on distance. So I'm going to pick this point, and I'm going to come in here and grade 1%, and on this one I'm going to come up 20 feet, and I'm going to go enter, enter, enter. Now this elevation here would be elevation only. Is I could come and say, okay, now from this elevation I add 0.67 feet to get my finished floor elevation. So I'm going to say 78.87 plus 0.67, which is 8 inches approximately, and that elevation here, this finished floor elevation, double click on that, endpoint, and I'm going to write 79.54. Okay, so that would be my finished floor elevation at that lot right there. Now I can delete this point, and I can move this over to this point here. All right, that's how I would figure out the finished floor elevation in this lot here. The other points that I would need to set, once I get this one, this line set, I would do the same process along this one. So over here, what I would want to do is look at which elevation's the higher. This elevation is higher than this one, so I'm going to go up 1% here. So I'm going to come over here, I'm going to go grade slope distance, and my start point would be here. Along this direction, I'm going to go grade of 1, slope of 1, and I'm going to set it at this intersection point here. And enter, enter, and enter. Now, once you get those set, you have to make sure, now take a look at this. This is 80.48 and this is 80.23. I need to confirm, and I'll use my analyze, that from this point here to this point here, there's 1%, and it's not. So in all actuality, this elevation controls. So I'm going to go grade and distance, start here. I'm going to bring it to this intersection, that direction. Grade is 1%, and the distance is this intersecting point here. Now change that. Elevation only. And now I check to make sure that this slope from this point here to this point here is at least 1%, and it is. So I would do this for the rest of the spot grades. Now for the finished floor, I would look at which was higher. So I'm going to look at these two. I'm going to look at 75 and 77, so it's going to come up 1%. Now I don't want so much slope that this is hard to grade. So I'm going to look at the slope between this point and this point. Oops. Click on points. Point to point. And that slope is 4%. So I would just add on to get the finished floor elevation here. I'm going to copy this over. And I'm going to add to here the 80.88. So I'm going to take 80.88 and I'm going to add 0.67 to it. And that's going to give me 81.55. So in this text, I'm going to change that to 81.55. That would be the finished floor elevation for this lot here. Now, I would go around and do this for the rest of the lots, and I would confirm that these grades, for example, this one's 83 and 76. So I'd see if this slope, click on points from here to here. So that slope is 7%. So I would probably want to do what I explained in the using the PowerPoint. I would do a steep slope here and then a shallow slope here. So what I want to look at, that's what would be on the grading plan. So I'm going to let you try these on your own. I'm going to work through a few of them and I'll post my solutions so you can see what it looks like. But to sit here and do each one individually, it'll get a little bit boring. But go ahead and take a look at the PowerPoints and the calculations that I have on Blackboard. Try creating points by slope and setting high points. You won't have any type B lots in this project. They'll all be A lots because they're all going to be draining to the roadway from here. All right? So that's it for this video.